Good morning. Okay, so we are going to work on 2.2 day one. So we just finished up section 2.1. We'll take 3 days to go through this section, and today's pretty easy. It's a nice little intro. A lot of this stuff you have seen before, so some of it will seem familiar. Okay, so remember what we've been doing, you guys, this whole time. Like if you collect data and you have a simple dot plot, the way that we've been describing data, the way that we've been doing all of this stuff is to imagine, right, drawing a smooth curve over the data that's been graphed. Okay, and that smooth curve that we have been drawing is what's called a density curve. Okay, and so there'll be a couple homework problems that ask you specific things about a density curve, and the two facts that you need to know are right here. It's always on or above the horizontal x-axis. Okay, so as we've always been drawing here, it's above the axis. It doesn't go down below. And the area underneath it is always equal to 1. Okay, so a density curve will always have an area of 1. And remember, the number 1 is equal to, as a percent, 100%. Okay, and so the reason that the area under the density curve is equal to 1 is because it will capture 100% of all of our data. Okay. All right, so that's just some basic facts about a density curve, right? Above the x-axis, area equal to 1. They have lots of different shapes. We know that this is symmetric, and we know that this is skewed right. And what they do here is they go back and they kind of reiterate something we've already learned, which is what's the difference between the mean and the median? Well, from the previous chapter, if it's symmetric, they're the same. If it's skewed, the mean gets pulled towards the tail, okay, which I don't think we need to go over again. That's just a review of that. Okay, we've talked about the mean being like the balance point, right? The median separates 50% of data here and 50% of data there. Okay. All right, so what we're going to do down below is a simple activity. We'll need a calculator, and I'll write down all these calculations for you. But what we're going to do is we're going to talk about, okay, for each of the approximately normal distributions. So this is a new description that we have not learned yet. Like, what's up with the word normal? When you guys see the word normal, something specific happens in statistics, and this activity is just going to kind of take us through and see if we can kind of look and see if we notice any patterns. Okay. All right. So here's a dot plot. It shows the weight of 36 Oreo cookies. So some basic stuff here. We would say n equals 36. N stands for the number of observations. The mean for the rest of this chapter, I know we've used X bar in the past. That's for a sample. We're going to use a population mean, which is like a lowercase u with a tail. It's pronounced mu, M-U. Okay, but that's the symbol for mean. Okay, and it gives us a standard deviation. We're going to use this new symbol that looks like a cursive R, kind of. It's a lowercase s in the Greek alphabet, sigma. Okay, so standard deviation is that symbol, and the mean is this symbol. Okay, so again, to keep this simple, there are 36 dots here. And what happened is that they weighed Oreo cookies, and then they took the weights and they put a dot and how much everything weighs. Now, you can kind of imagine here, right, that if you drew a smooth curve over that, that would be representing a density curve. Okay, what this exercise is going to do is it's going to go check out how much of the data is within one standard deviation of the mean. Okay, and so what we do is if our mean is 11.392 and our standard deviation is 0.081, what we're going to do here is we're going to take our mean, 11.392, and we're going to add one standard deviation and get this value, and then we're going to subtract 1 to get this value. Okay, and so if I take my calculator out and I take 11.392 and I add one standard deviation, or 0.081, I get 11.473. If I take 11.392 and subtract a standard deviation, I get 11.311. So I'll write those in here, 11.311 up to 11.473. Okay, so let's go up here and let's draw where we ended up at. So 11.3 is right here. 0.311 would be right about there, right? And if I go up to 11.473, it wouldn't quite be at 11.5, so we wouldn't quite capture that dot. Okay, well, Now they want to know, well, what's the percent of the data that is within those barriers? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25, 26. So it seems like there are 26 data points out of, remember, 36, which is approximately 26 divided by 36, 72%. Okay. All right, so let's do the same thing, and let's do 2 standard deviations. So if I take 11.392 and I add 2 standard deviations, so 2 times 0.081, right? Or plus 0.081 plus 0.081, either way works. We get 11.554. And if I take that value and I subtract 2 standard deviations, I get 11.23. Okay, so let's see if I can switch colors here. So now let's go down to 11.23, so somewhere right around here, and up to 11.554. So this is 11.5, and then this is 11.6. So right in the middle would be 11.55. So 1, 2, 3, 4, 5. So 2.5. So somewhere right around here. Okay. And so how do we calculate the percentage within 2 standard deviations of the average? Well, we know that these dots were 26. So let's just add the other ones. 27, 28, 29, 30, 31, 32, 33, 34. So 34 out of 36 is approximately 94% of the data. Okay. All right. So I'm going to fill these numbers in for you here. If you take away 3 standard deviations, we go all the way down to 11.149. And if I add 3 standard deviations, I get 11.635. Okay. So again, now we're out here 11.635 and down to 11.1, which would be way down here. Okay. And you can see that within 3 standard deviations, we've captured all of the data. All right. So what are we doing? Let me pause and remind you. So they just threw this new vocab word at us, normal. We know what a distribution is. A distribution is this dots, this graphical display. So what does this normal distribution mean? Well, I haven't given you the exact definition yet, but so far what we've done is we've said, look, our mean is right around here. Okay. And if we go out 1 standard deviation each direction, plus and minus, we capture around 72%. If I go out 2 standard deviations, it looks like I capture 94%, and 3, I capture all of the data. Okay. All right. So let's just kind of solidify this one more time. Easy decimal work, and I'll fill in the decimals for you. Okay. So let's go through and write down what we know. It's a dot plot showing 50 students. So we know that n is equal to 50. This is scores on an algebra test. The mean, which is mu, right, or that fancy u, is 76.4. Okay. The standard deviation is 7.9. Okay. So let's go down here and fill this out now that we know what we're doing. So we're going to take 76.4 and we're going to add 1 standard deviation, which is 7.9. And I get 84.3. And if I subtract 1 standard deviation, I get 68.5. Okay, so let's go up here. 84.3. So you got to check your dots here. So this is 80, this is 90. So 82, 84, 86, 88, 90, right? So we want 84.3, somewhere right around there. And then 68.5, 62, 4, 6, 8, and a little bit, right, would capture that. Okay, so to get a percent of the data that falls within 1 standard deviation of this mean, which is right around here, okay, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 32, 33. Out of 50 data points, well, you just double that to get it out of 100, and you would get 66%. Okay. All right. If we go 2 standard deviations, again, I'll do this for you to save some time. If I add up 2 standard deviations, this is 92.2. And if I go down 2 standard deviations, I'm at 60.6. So 60.5 would be right here, right? Well, I'm sorry, this is counted by 2. So this is 61. So we're going to capture that guy. And then up to 92.2 would be 92. And so we have our 33 here, 34, 35, 36, 37, 38, 39, 40, and then 43, 44, 45, 46, 47, 48. And 48 out of 50 would be roughly 96%. Okay, and if we go 3 standard deviations, I get 100.1. And when I subtract, I get 52.7. Okay, so all the way down here and up to here, we have 100%. Okay, and so it kind of seems like we can recognize a pattern. Right? This is real data. I didn't give you a formula, okay, but if we look at what happened here, if I can zoom out, it seems like within 1 standard deviation, it was around 72, 66. That's kind of far away from each other, but we'd say somewhere from 65 to 75. 2 standard deviations, 94 and 96. That's pretty close, so right around 95. And then it seems like when you go 3 standard deviations away, you capture all your data. Okay, and that's all we're going to do down here is we're going to summarize it. And then tomorrow's lesson, I'll give you an actual fact about normal distributions. Okay, so it says both the distributions above were approximately normal. There's that word again, based on the examples about what percent. So within 1 standard deviation. Within 1 standard deviation, we said 65 to 75%. 2 standard deviations was right around 95%, and 3 we came up with around 100. Okay, now this is what statistics is all about. This is not fact yet. If we did this, right, imagine if we did that exercise 4 million times on data. That sounds awful, and it would be awful. But then we could take all 4 million examples and look at what we got 1 standard deviation away, and we could maybe average it out, and we would get a really good approximation for what happens. Okay, and that's how they come up with this rule that I will give you tomorrow. Okay, you can see down here your homework. It will be posted on Schoology as well, page 108, number 25 to 32. Okay, guys, take care.